Hello, welcome to a demonstration on multiple regression analysis. This is a very interesting data set. It's a data set for home sales. And we will be examining the two independent variables. That's the square footage and the age of the house, and the selling price will be our dependent variable. That's what we're trying to predict. So these two are going to be the predictors, and the selling price will be what we are actually predicting. So of course, respectively, we call the square footage and the age the independent variable, unless that's actually new to you, and the selling price will be the dependent variable. This particular data set is a little bit unique because it is one independent variable that has a negative correlation. Again, when we get to that, we'll be able to explain it, interpret the coefficient, so that we can better understand what this actually implies in our interpretation. So it's very, very, very important. And again, you're going to find some unique scientific notations in the results that we're going to generate from this particular multiple regression statistics. And I want you to become familiar with the correct interpretation of those scientific notations, so that in future when you encounter them, you do not misread them. It's very important to make sure that you have some basic understanding of what those scientific notations would be, right? But of course, as for now, it's meaningless because you're not looking at the results yet. But again, when we get to that, I just wanted to prime you for that, so that at least you are ready to learn. And of course, this demonstration is going to be a little bit long, but it's actually worth your while to go through it. And I have no doubt that you're going to learn a lot of stuff in this particular demonstration. So now for us to generate multiple regression statistics using Excel, we need to go to Data tab. So once you click on Data tab, you should be able to see Data Analysis on the top right-hand corner. If you do not see it, it means that it's not added in. So it needs to be added in. By default, it does not come standard with the Excel application. It's actually there somewhere hiding. So what we have to do is we go and activate it. So we go to File, and then under File, we find Options. Right, and opens up a dialog box here. Under Excel Options, you'll be able to see Add-ins. Click on that, and then you'll be able to see Manage Excel Add-ins. All you have to do is click on Go. And then opens up this dialog box where there are all different statistical functions that you can activate. So the reason why you were able to see data analysis on mine is because I had a analysis 2-pack selected. So you need to have a check mark on it and then go ahead and say OK, so that it can show up there. Now that we have data analysis activated, all we have to do is just click on it, and opens up a dialog box where we can select the analysis tool that we actually need. In this case, we know we want to do regression analysis, so therefore we look for regression. If you can't see it, you can scroll down, and there it is. And then, okay. Then now we have the working dialog box, in which we are required to select the range for input Y. Input Y would be our dependent variable. Okay, so we select the selling price. Okay, then we can scroll back up so that we can see the top of the file where the file actually begins. And then we click into the input X range, and that's going to be our independent variable. That's the square footage and the age. So like that. Okay, then we can scroll all the way up again. Then of course you were to specify that the first row is actually made up of labels. So we put a check mark on that. And by default, the statistics are going to be generated at confidence, 95% confidence level. So it's either we select that or we don't. It does not really matter. By default, that's what's actually going to be. Of course, if we wanted to change that, depending on the kind of research we'll be doing, there are situations where some may say confidence level should be 90%, right? Again, that's a discussion for another day. Now, finally, the final section will be the output options. So in other words, where do you want your results to be placed when they're actually generated? In this case, I want them to be on the same page. So I want output range, click here, and I want there to be placed beginning cell E2, right, like that. And then go ahead and say OK. And then it generates the summary output for your regression statistics. So now what we're going to do is just to do some housekeeping here. We just want to make sure that we can expand the columns large enough so that we can read all the information that's actually available in there. Right, now a little bit of housekeeping as well. You notice that the lower 95% and upper 95%, they are actually repeated. So the last two columns are redundant. So I select those two and delete them so that the presentation is a little bit cleaner for our interpretation. Now, okay, so now here what we're looking at are regression statistics section. Multiple R simply is measuring the strength of the relationship, right? So it's saying it's 88%. That's fairly high, right, by any standard, right? Which means that could be a good indicator that probably we are going to find some statistically significant relationships in here, right? So it's simply just measuring the strength. And then R square is measuring the coefficient of determination. So in other words, it's telling us that the two independent variables, that is the square footage and age, explain about 78% of the variation in the selling price. So the other 12% we don't know. So that actually would be a good indicator that probably maybe our model can actually be improved if we can figure out what the additional variable or variables would be, so that we can actually improve the predictive power of our model, right? But otherwise, for now, it's saying 78% can actually be explained by these two independent variables. That's pretty high enough as well, right? So generally speaking, we use the adjusted R square because it's actually adjusted for the sample size. It takes in consideration that maybe the sample size is actually a limitation. If your sample was much longer, maybe there will be an improvement, right? Standard error just telling us about the data dispersion, how spread out the data is, right? And of course, the higher the number, the more dispersed the data will be. And usually you can just visually inspect the data to see if that is actually holding true as well. Okay, otherwise observations is just the sample size. Now that takes us to the next section, which is ANOVA, analysis of variance. Generally speaking, the main statistic that is significant here is the significance F, because simply telling us whether the two independent variables relationship with the selling price, the dependent variable, are statistically significant. So collective statistical significance of the two variables, right? Here it's actually telling us that yes, it is. Now, how do we know that? We are measuring, remember we said we're generating our statistics to 95 confidence level. So therefore, our threshold is 0.05. So for the relation to be statistically significant, it should be smaller than 0.05. But now, when you actually look at this number here, it looks a little bit confusing, isn't it? Because it appears as if it's 6.61457. Then there's an E minus 38, right? Now that actually tells you that this is a scientific notation, right? The number has actually been abbreviated because it's up to 38 decimal places. So there's no way of actually writing 38 decimal places here and feeding it, and then it makes sense, right? So it does not make sense to actually do that. So because of that, the number is actually abbreviated using a scientific notation, where we are saying that these numbers that you see on the left here, they actually begin at 38 decimal places. I can demonstrate that for you so that we can actually regenerate this number, right? Just to prove that particular concept. So we can say 0 point, then we type in 37 zeros, and then we enter that number. So 0.37 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, and then 6, 6, 1, 4, 5, 7, right? You can see, and already you can see this number is way smaller than 0.05. So if I press enter, you see we generate exactly the same number right there. So it's important for you to actually understand that. Now, on the other hand, you may also have seen some scientific notation on the sum of squares here. It's simply saying these numbers are too large, right? Whereas on this side here, when it's actually minus 38, the numbers are too small, right? So now, what does this actually mean? Okay, I can use a different illustration for that. For example, if we had 3.2, let's say E-4, right, would know that this number is actually 4 decimal places. This number is actually 4 decimal places. So therefore, it would be a 0.0123, then 32, right? It will be like that because the number is too small. But now, what about if it was 3.2 E plus 0.4? Okay, it actually means that the number is too big, so it's 32. So then 1, 2, 3. Okay, so it's actually the other way, right? So I just wanted to highlight this. This is a very, very interesting. It's a lot easier to interpret this one here because you know it's decimal places. But now, when it's actually plus, telling you this number is too big for us to even fit it in this particular column. And it's very true with sum of squares because when you talk about sum of squares, we are basically what we're doing is that it's a number that we arrive at after measuring the distance between the data point and the mean, and you squaring it up, so multiplying it by itself. Then add all those numbers together of all those data points, right? Those differences. So those numbers are always very, very large, the sum of squares, right? They are always very, very large. So because of that, that's why there's a scientific notation which says plus 11 means the number is too large, minus 38, the number is too small, right? So it's important to bear that in mind. So I thought I would do this kind of demonstration so that at least, again, we can cover that kind of a base because it can come from time to time, and it's always very important to make sure that you do not misinterpret those numbers and you know what they actually signify. All right, so here we have an idea that the two independent variables collectively are statistically significant, right, in their relationship with the selling price. Now, we now move on to the final section here. Okay, so in this final section here, we focus more on the p-value, right? We want to see individually, is square footage statistically significant? Yes, we can see it to 38 decimal places. So this number is definitely smaller than 0.05. What about age? It's 0.005. So it's definitely smaller than 0.05. So these two independent variables with their relationship with the selling price or the dependent variable, they're statistically significant. What does the coefficient actually tell us? It does tell us that for every increase in square footage, the value of the house will increase by $61, right? But it can be as low as $54 or as high as $67. Okay, so it can actually range anywhere in between those two. But on average, it's $61. How do we know that on average it's that? We can actually calculate average here very quickly. The average of these two values, you can see that it actually gives us the coefficient. And of course, the same is true for age. But now, funny enough, age, you see that it's actually negative, right? Because it is a negative correlation. So the age of the house has a negative correlation with the selling price, because the older the house gets, the lower the value of the house. So here simply telling us that for every additional year that is added to the house value decreases by $403, and can be as lower, can even be lower in a worst case scenario to 685, and can also be as high as negative 121. So it can range anywhere in between the two. As again, as we've already seen, the average of those two, the lower and the upper, is what we have here, the coefficient. So there is your negative correlation interpretation right there. And age of the house is quite meaningful as well. It doesn't mean that you may not have a data set where there are some outliers, where it's actually going the other way, depending on maybe the house could have been renovated, or maybe the location of the house, or maybe the house was completely destroyed and was actually built again. And so again, that can as well be some of the reasons why there could be some variation in that particular regard. But at least here, generally speaking, from this particular data set, we can conclude that square footage is a positive a correlation with the selling price, and the age is a negative correlation, but both of them are actually still strong predictors of the selling price. Otherwise, that concludes a detailed demonstration of multiple regression, where there is an independent variable with a negative correlation, and also in a situation where we've got sum of squares with numbers that are too large, and also statistical significant numbers that has a very small numbers as well. Hopefully you've actually been able to capture a wide range of key learnings from this particular demonstration. Not only did you get to understand what regression statistics actually mean here, also understanding the significance a test that's actually provided here, and how to interpret scientific notation types of numbers in both small numbers and also large numbers, and also understanding the correct interpretation of the p-value as well as the coefficients. So hopefully that gives you a very solid grounding in understanding multiple regression analysis. Thank you so much for watching, and bye for now.